Dear students, today I will talk about inertial frame of references as I have started in previous lecture. At first, I will draw the two frame of references. One is S, another is S prime. Two inertial frame of reference. Here we will define the position vectors again and I will show how to transform from one frame of reference to another. This is my S frame, X, Y, Z. This is my X prime. The drawing is not so good. Y prime, Z prime. This is my S prime. Now S frame is at rest and S prime frame is moving with velocity u along x-axis. Now, here are three-dimensional coordinate system, but today I will tell you that in this case, I will take another coordinate, time. So, time is taken as another coordinate or dimension. So why time? If we talk about any event occurring at any point in space, say at this point P some event is occurring. So the position of the point where the event is occurring, we have to know that position with respect to frame S. That means the observer is sitting at the origin of the frame S and with respect to frame S prime. That means the observer is sitting at the origin O prime. So positions are important and also time is important. So first define for S prime frame, we will define time as t prime and for S prime we will define time as t. Now let's say this observer has a clock and this observer also has a clock. Since S prime frame is moving along x-axis, so sometime at any time in space these 2 points overlaps O and O prime. There is some point when O and O prime overlaps. Now, this clock and this clock, the observer just started the clocks when both overlapped. So, T started and T prime started. Both started when? When started? At a time when O or O prime say O prime coincides with O. So their clocks are started at that point. So the countdown starts at this point. And now this type of transformation, which is the Galilean transformation, it is assumed that time is universal. That means if we changes frame, if you go one point to another point and any type of frame, time will be universal. The way the time changes is same for the both frames. So in Galilean transformation, time is universal. That means both the clocks ticks in a similar way. So the countdown started when O and O prime overlaps. That means when t is equal to t prime is equal to 0 concept is set as the initial time. So it is our initial time. Now as time elapses and after some time, these are the position. Here is O and here is O prime. Now some event is occurring at point P. So if the event is occurring at point P, what will be the position at? I have already discussed the position vector with respect to S and position vector with respect to S prime. Now I have to mention another thing, time. So we have two frames, we frame S and frame S prime. So in frame S, what is the position vector? R. What is R? R is equal to xi plus yj plus zk. And in S prime, R prime. R prime is equal to x prime I plus y prime j plus z prime k. Now let's say some event is occurring at P. Some event at P. So what is the time? As the observer, the origin of S measures, he measures time t. Similar event at P prime. So time measured by observer at O prime, what it will be? It will be t prime. So this is measured by observer at O. So you say the coordinates, if we use 4-dimensional coordinate, how we define the event? We define the event as x, y, z, t with respect to S prime, and with respect to S prime, how we define the event? X prime, y prime, z prime, t prime. So now what is our aim? Our aim is to find out the relation between these 4 coordinates and how we can transform these coordinates from one frame, from S frame to S prime frame.